A compound made up of carbon, hydrogen, and chlorine contains 55% chlorine by mass. If 9 grams of the compound contains 4.19 times 10 to the 23rd hydrogen atoms, what is the empirical formula of the compound? So to determine the empirical formula of this carbon, hydrogen, and chlorine compound, we need information about the number of moles of carbon, hydrogen, and chlorine. So either the number of moles or the number of atoms, same idea. Let's start by determining the mass of hydrogen atoms in the compound. We've got 4.19 times 10 to the 23rd hydrogen atoms. Now to get the mass of hydrogen atoms, we need to be in moles of hydrogen atoms so we can use the molar mass. So this is a literal count, so we just need to say for every 6.022 times 10 to the 23rd hydrogen atoms, there's 1 mole of hydrogen atoms. Now that we're in moles, we can use the molar mass of hydrogen, which is just going to be the atomic mass of hydrogen, 1.008. So there's 1.008 grams of hydrogen atoms for every 1 mole of hydrogen atoms. Okay, multiplying this out, 0.7013 grams. We also might as well just go ahead and pull the moles of hydrogen atoms. So dividing this by this, 0.6958 moles. Okay, but now that we have the grams of hydrogen atoms, we can divide this by 9 to get the percent hydrogen. Add 55%. Now 100 minus this is the percent of carbon atoms by mass. 37.2% of carbon. So multiplying that by 9, so divide by 100, multiply by 9, you have this many grams of carbon. So let's convert this to moles. Molar mass 12.011. .2788. Okay, now let's convert the grams of chlorine to moles. So 55% of 9, 4.95 grams. Molar mass of chlorine is 35.45. 0.1396 moles of chlorine. Okay, so now we've got the molecular count information for each of the elements in the compound. All we need to do now is divide each of these mole counts by the smallest count. So 0.1396 divided by 0.1396 is 1. 0.2788 divided by 0.1396 is 2. And 0.6958 divided by is 5. So there we go. The empirical formula is C₂H₅Cl.